everyone. Welcome to our course Understanding Internet of Things. Introduction to IoT. Internet of Things have been a prominent technology area for past few years. The IoT devices also improves the efficiency of operations for the existing applications. These devices are also capable of being enhanced depending on the requirements of the user. The inclusion of wireless networks in IoT, the range of IoT devices have increased several folds. In this course, we are going to cover the following modules. Module 1, Internet of Things. Module 2, Building Blocks of IoT. Module 3, Open Source Hardware. Module 4, IoT Architecture and Pin Diagram. Module 5, Raspberry Pi and Projects. Module 6, Communication Protocols for IoT. Module 7, Advanced Technologies in IoT. Module 8, Introduction to Arduino and Projects. Module 9, IoT Application Layer Protocols and Projects. Module 10, IoT Cloud Services. We are going to cover each of these in coming slides. IoT became very popular in the present world. The reason for that is its versatility. It connects multiple fields or sensors to cloud and hence make their data accessible. On the other hand, it also allows the commands sent from the user to reach these sensors or devices via cloud. Hence, by bringing various technologies and sensors on the same platform, IoT has made it possible to approach multiple domains at the same time. IoT is only possible with Internet. Internet acts as a medium to transfer information from various sources in various formats to possible destinations. It connects everyday information to various devices via different platforms like electronics, embedded systems, softwares, etc. This collected data or information serves the purpose of measuring parameters like temperature, humidity, etc. Ranging from a simple monitoring application to complex decision-making applications, it is possible to implement the IoT. Another important feature of IoT is its connectivity. With the inclusion of wireless networks in IoT, the range of IoT devices have increased several folds. From a single room to a multi-story building, IoT is able to span the distance and perform effectively. As the high-speed electronics are coming into the market, so is the IoT device speed increasing. With more and more advanced microcontroller and processors, present IoT devices are able to achieve much higher speed compared to their predecessor. A very simple example of IoT can be seen around us when someone controls a light bulb using his or her mobile. From this application to smartwatches that we wear, IoT has advanced very quickly. Not only these, smartwatches do as commanded, but their intelligent algorithms are capable of performing decision-making for raising some alarms. Hence, with IoT, we are capable to create devices and applications that are able to perform multi-operations without much intervention. They are also able to perform decision-making if they are built to do so. As the semiconductor electronics is progressing, so is the size of IoT devices. With more and more smaller chips and ICs, IoT devices are also becoming smaller. All these features have made IoT devices run the market currently. As the time predicts, we will be seeing many more of such devices in future application. Why we use IoT? So, anything or any parameter that can be measured up to considerable accuracy using affordable sensors can be accessed through IoT. This is the actual purpose of IoT. It helps in measuring parameters or conditions of a particular system in real time via internet. With the advancement of embedded system, this purpose was already fulfilled but with limited sensor types. Now with IoT, heterogeneous sensors can be added to a simple system without making major changes in the underlying hardware. The answer to the question, why we use IoT, is very simple. Hence, it helps in connecting with multi-platform hardware. It also makes possible to collect information about the intended environment, and finally, it maintains a distinct address for each input. This makes IoT very versatile technology. The available hardware for IoTs have been becoming increasingly affordable, and hence the work in IoT has increased many folds in past few years. In later sections, we will be looking into the applications and some such hardwares used to create standalone IoT devices or applications. Advantages of IoT. With IoT, it is also possible to uniquely identify these objects with the help of virtual IDs. This enables monitoring or controlling of physical environment in real time. Due to these advantages, IoT have wide applications from simple monitoring tasks to complicated control system environment. As the sophistication in the storage devices and channel data transfer have increased, the IoT has made it possible to monitor physical parameters continuously, thus providing more accurate monitoring of the system. The continuous data acquisition also helps in better fault identification and fault mitigation. The application range of IoT is from small enterprises to very huge industry. This flexibility arises due to the capabilities mentioned above. Apart from this, due to its multi-platform capability, IoT is able to handle smallest to much complicated data management applications. As the advancement in the field of communication are progressing, IoT is also increasing its range from small distance applications to large distance applications. Application of IoT. The application of IoT can be seen in multiple fields. Some of them are: first, agriculture, for measuring soil and environmental condition. Second, wireless sensor networks. Third, building management systems, for example, AC control, power control, etc. Fourth, personal asset monitoring or management, for example, vehicle status, etc. Fifth, in building smart homes and cities. Sixth, telemedicine and healthcare, for example, during corona, video consultation. Seventh, security and surveillance. Eighth, energy consumption, for example, smart meters and power savers. Ninth, embedded systems like mobile, chips, etc. and many more. Every day, new and new applications of IoT are being invented and used in making our day-to-day life easier and more tech-savvy. How IoT works. For any application, the IoT backbone remains the same. To work, IoT needs input data which travel through proper channel and are sent to user interface in desirable format. The inputs to IoT are provided by various sensors like humidity sensors, temperature sensor, voltage sensors, etc. These sensors essentially serves the purpose of data collection. Once the data is collected, it is sent to the main IoT system by various channels. These channels can be wireless Bluetooth or internet, etc. Hence, if the connectivity of the sensor is proper, then the data transfer is also reliable. Once the data is received, it is processed to extract useful information and is converted into user-required format. After the processing, this data is sent to the user interface for further operations. The user may choose to simply display the data or further process the data. For example, with soil condition monitoring, the purpose is to simply display the soil data. While with more advanced applications like building temperature control, the requirement is to also control the building temperature apart from its measurement. displays an animation depicting the operation of IoT. In this animation, it can be observed that the input sensor and actuator data is collected by the IoT gateway. This data is then sent to a switch, which in turn helps in processing the data. If required, this data is stored in the data lake. From here, the data is transferred to the IoT application cloud. How to start with IoT? To start working with IoT, a few fundamental concepts are required like, first, understanding of IoT, which we have completed for now. Second, understanding building blocks of IoTs, that is, basic IoT framework. Third, understanding basic hardware required to start small IoT project. Fourth, understanding basic programming language to work. Fifth, getting hands-on practice. Following all the above topics will help you gain a good hands-on experience of few basic IoT applications. Based on these basic applications, you can definitely develop more advanced and complicated applications. Building blocks of IoTs. So, we will start with the second part of our module, which will focus on various building units of IoT. Commonly used IoT devices. Most common ones are sensors like Hall effect sensors, thermistors, photodiodes, LDRs, etc. Some other hardware includes physical connectivity devices like wires, connectors, etc. To build a small device, commonly used devices include LEDs, breadboards, wires, connectors, motors, adapters, etc. Key building blocks. After looking at common IoT devices, we will discuss IoT framework in detail. From the slide, we can see that IoT framework starts with sensors and actuators acting as input. These sensors and actuators are also referred to as smart things as they are capable of sensing the environment around them. The collected data is then transferred to the middleware or computer station via data transfer network. Commonly used networks include Wi-Fi, Bluetooth, Zigbee, broadband, etc. The middleware collects the data. As per the need, it can also store and/or process the data. The purpose of middleware is to extract the useful information in the desired format. This information is then communicated to the end client for display or further processing. Since IoT assesses various platforms at various stages, hence it follows some protocols to exchange information. These protocols are very important in maintaining the standard and authenticity of the data. Sensors. Let's look at each component in detail. First part of IoT includes sensors. As discussed before, sensors are specialized data collectors. They measure the environment condition and convert the measured values into digital reliable information. This information is then sent on the network. There are multiple sensors available nowadays which can measure multiple parameters like proximity detection, acceleration, tilt, etc. Some of the common sensors are listed in this slide. In the next slide, the properties and measured value of these sensors is mentioned. Actuators. Another important category of IoT devices include actuators. These actuators represent various energy generators or transformers. Their work is to convert energy from one type to another. Most common example is motor, which converts electrical energy to rotational energy. These actuators can be broadly categorized into 4 categories: motors, linear actuators, relays, and solenoids. Linear actuators. Linear actuators are the actuators that create translation motion, that is straight line motion. These actuators are used in machine and industry tools. Some peripheral devices like disk drives, printers, etc. also use linear actuators. In contrast to linear actuators, relays and solenoids are energy storing and redistributing actuators. Relays are electronically operated switch, but the on-off stage of a relay can be controlled based on a controlling input. The advantage of relay is that it takes a very small power to operate and generate output. Hence, they are used as controlling elements for motors, heaters, etc. Solenoids, on the other hand, are controllable electromagnets. They are used for latching, locking, or triggering controls. Motors. Most common actuators in this stage include motors. Motors can be used in multiple ways. They can act as actuator by converting digital input to mechanical rotation output, or they can also act as sensors where they can generate the data sets that constitute big data. There are intelligent motors which are equipped with DSPs or microcontrollers. They can sense and control the amount of rotation as per the control input. There are multiple uses of motors which include usage from common household equipment like washing machine etc. to heavy industrial machines and transport devices like planes. Types of motors. Motors can be divided into many categories. First, DC motors. Second, servo motors. Third, stepper motors. This division of motor is based on their construction and principle of operation. DC motors are commonly used motors. They are also cheap and have easy operation with no feedback. Their simple task is to convert simple electrical energy to mechanical energy. These are continuous operation motors and very basic in their construction. For small-scale projects, it is the motor of choice. Servo motors are small DC motors with potentiometer acting as feedback. The shaft of motor is capable of being placed at specific angular position by sending proper servo command. The potentiometer sends present position that is used for feedback. A servo motor in terms of construction is basically a two-wire DC motor connected to a potentiometer and a gearbox. The gearbox is meant for controlling the motion of the motor as per commanded value. Stepper motors are discrete step DC motors. The discrete step in a stepper motor are achieved by using multiple coils. It has capability to move to the commanded position and keep itself locked at that position till the next command is issued. Thus, it has computer-controlled stepping. Power adapter. For any device to run, power is the key requirement. For IoT devices, their scale makes it essential to use power adapters. The job of a power adapter is to bring power to the level of IoT device so that the device does not burn. The power adapter used depends on the IoT board power level. Any power adapter must have 5 main characteristics. First, over temperature protection. Every power supply has a working temperature range. Since most IoT devices works at room temperature, hence power adapter must also work in same range. Excessive temperature may cause the nature of electronic circuit to change. Second, overcurrent protection. Every electronic device works well within its operating current range. Thus, overcurrent protection means to ensure that the power adapter is working within this limit. If overcurrent protection is not present, it may not only lead to adapter loss but may also cause permanent device damage. Third, surge protection. This functionality protects the device against random and rapid changes in the power spikes. Fourth, ground protection. Ground protection means that the device is well connected to the ground. This is achieved by using a protective conductor to dump the DC current to ground. Fifth, isolation. Isolation of adapter from the rest of the circuit ensures that the main device does not get affected due to power surge in the power supply or adapter. These characteristics ensures that power adapter protects the device at all times with power glitches. IoT architecture. After understanding common hardware parts of IoT, now is the time to understand its architecture. There are no common consensus on the architecture of IoT. With every IoT device, the architecture changes as per the application. But a general idea of IoT architecture can be obtained from the next slide. As discussed in IoT framework, IoT devices have four main elements. These elements prepare the four stages in IoT architecture, which are first, sensing layer, second, network layer, third, data processing layer, fourth, application layer. From this slide, we can see the networked things in IoT, that is, wireless, actuators, and sensors serve as stage 1 in the architecture. These devices may be wired or wireless. For wireless devices, the connection can be LAN or PAN depending on the range of sensor. The second stage of IoT includes Data Acquisition System (DAS) devices. These are internet gateways which receive data or set of data over Wi-Fi, wired LANs, or the internet. The stage 2 devices perform data aggregation and conversion functions using DAS. The DAS collects the data from stage 1 and converts it to applicable digital format to process it ahead. Sensors are many times slow compared to the other IoT devices, hence this stage also helps in maintaining the speed of operation. For that, multiple options are used including LANs, Wi-Fi, Ethernet, etc. and WANs, GSM, 5G, etc. These gateways are also capable of transmitting data in both directions. So, with the help of proper encryption tool and security keys, this layer helps in creating a very secure communication channel. With advanced encryptions and algorithms, this layer provides security from data leaks and hacks. Some advanced versions may also include malware protection or decision making or filtering, but it varies with the hardware and sensors used. Stage 3 of the architecture consists of devices that analyze and process the data. These devices are called Edge IT devices. They are responsible for transitioning the data from digital form to acceptable cloud form. The applications access data from this layer or stage and displays it into proper format. Depending on the requirement, the data may also be taken from it for further processing. Hence, here edge analytics come into play. These devices can be hardware and software gateways. They are placed near to stage 1 devices, creating a wired or wireless closet. Stage 4 constitutes of data center or cloud platform. Here, again analytics is performed to ensure data is in proper form for display or storage or management. This stage may happen inside cloud or on hardware device. Here, the data is available for the end user. The end user may be from any domain like agriculture or defense or healthcare, etc. Open source hardware. From this slide, the discussion will focus on open source hardware. The knowledge of open source hardware is the stepping stone to build any IoT-based project. Before starting the project, it's essential to understand the available hardware in the market and choose the next one suited for the application. With advancement in the field of IoT, many such hardware are available, but we will be focusing on handful hardware that are easy to install, use and build. Raspberry Pi. Open source hardware means the hardware that are available for anyone to purchase and work on. The software for this device is also available as free document on the hardware website. The parts used and the working of the hardware is also available on the website. This hardware consists of basic parts which can be used to design most applications without much extension. One of the common open source hardware is Raspberry Pi. Raspberry Pi is a mini computer capable of performing many functions. Due to its small size and huge capabilities, it is currently one of the most used hardware around the world. It also comes in many configurations, and as per the project requirement, the configurations may be selected. The details about it can be accessed from many websites and blogs, including its official website, that is www.raspberrypi.org. The next common open source hardware is Arduino Uno. It is a microcontroller board with various available configurations. For the first time for IoT enthusiasts, it is a great choice. But due to its restricted hardware, it may require a lot of other hardware attachments to build bigger projects. Apart from hardware, Arduino also includes a software and an IDE integrated development environment. The IDE is meant to provide visual understanding and display while working on Arduino. Another Arduino certified open source hardware is Intel Galileo. Currently, this hardware is not used much. It is also a microcontroller board but based on Intel Premium class chip. The device uses Arduino shields to communicate with the system. Good thing is that these boards work well with Arduino IDE, so the same can be used to write codes. It has many industry standards IOs which makes it useful in small-scale industry applications. NetDuino is another open source hardware based on .NET Micro framework. It uses ARM Cortex 32-bit RISC ARM processor. It is used by a little advanced community of IoT developers. It is compatible with Visual Studio, Xamarin Studio IDEs on Windows and Mac respectively. It also has Wi-Fi and intranet connectivity models. The designer can select from a wide variety of available models from NetDuino. A lot of open source activity help is available online for its usage and debugging. Being an embedded platform and ARM-based technology, it is faster. It has a wide presence of 20 GPIO ports with SPI, I2C, UARTs, PWMs, and ADC channels. This makes it a very efficient embedded system board. Raspberry Pi and projects. To start working in IoT domain, for a beginner, Raspberry Pi is an amazing device. It is affordable and manageable. The IDE and support for Raspberry Pi is also great. Raspberry Pi needs its own OS to work on. That OS is called Raspbian. Since the inception of Raspberry Pi, Raspbian has been also improving. It is also possible to run Raspberry Pi with other OS apart from Raspbian like Ubuntu, Mac, or Windows. But Raspbian has an advantage of being lightweight and specially tailored for 32-bit system. While starting with Raspberry Pi, we will focus on installation of Raspbian OS. Once the installation is complete, we will proceed with our projects. The projects will include first giving a simple instruction to Raspberry Pi and generating the output. This will include gluing a LED with the help of laptop via Raspberry Pi. With this project, we will gain the knowledge of operating the Pi GPIO port. After establishing this project, we will move to little difficult project, that is, to build an alarmed motor sensor. The aim of this project is to design a simple motion sensor that will generate an alarm when it detects motion in a certain area. This will help us in getting familiar with noise generation using Raspberry Pi. With the above two projects complete, we will be able to move to the next project that will include wireless sensing. In this project, we will be creating contactless body temperature monitoring system. With the current COVID scenario, this project will turn out to be very useful. In fact, if you are motivated enough, you can build more advanced project depending on this one. If you have any queries, please get in touch with us by typing your comment in the comment section. Thank you for watching. Do like and subscribe to our videos. So what are you waiting for? Join us for the course and do subscribe to our YouTube channel and don't forget to press the bell icon. Also, if you like our videos, don't forget to hit the like button and share our videos.